Okay, let's do this. Hold on, let me send the link out real quick. Okay, let's do this. Damn. The water in the river moves uniformly to the east, so this way. East. Oh my god, it's a horrible arrow. Here, this way. That's the way it's going. With the speed of VR, 2 meters a second. 2 meters a second. A boat on the river starts from the south edge of the river. And here, actually, I think we get a diagram of the river. Oh, yeah, perfect. I don't even need to draw this then. Perfect. Okay. So, this is VR right here. This is 2 meters a second. And boat on the river starts from the south edge of the river. So over here, this boat, they're talking about this boat. And the boat's motor gives the boat a constant speed of VB, 5 meters a second. So this is 5 meters a second. The width of the river is 40 meters, so this whole thing, W is equal to 40 meters. And when the boat reaches the north edge of the river, it has an eastward displacement of x relative to its starting position. So is this the starting position? Wait, what? When the boat reaches the north edge, so over here, it has an eastward displacement of x relative to its starting position. But x is from here to here, and its starting position is right here. It's a little bit confusing. Okay, so we already did that. Okay, I guess. North and east, it tells us which one. That's good. Calculate the magnitude and direction of the relative velocity v of the boat with respect to the shore of the river. Okay, so the relative velocity, I'm pretty sure that's, I'm pretty sure that's just like the diagonal line. Let me see. Relative velocity. Oh, it's just in reference to frame A. Okay, okay. Let me just shorten that. The relative velocity direction of the relative velocity v of with respect to the shore of the river. So I'm pretty sure this is asking for. I'm like, I don't even know. I'm a little bit sure that it's gone from like VB to VR. Basically, it's like asking about the hypotenuse. If you were to take this, move it over here. VR. If you move it over here, now this is over here, 2 meters a second. And basically just find, okay, how far is it going to move with respect to the shore of the river? But with respect to, Damn. This is such weird wording. Calculate the magnitude and direction. Okay, that's pretty easy. At the relative velocity v of the boat with respect to the shore of the river. So I'm just guessing it's this. Oh, I'm gonna just do that. Okay, so start here. Hold on, there has to be a way to do this. respect to the shore of the river, show all your work. How much time will it take the boat to cross the river? I'm pretty sure it's asking that. I'm like, I don't even know, like 80% sure? Let's just do it, see how it works. So, with respect to the shore of the river, we find this. That's 5 squared, because, you know, Pythagorean theorem. 5 squared plus 2 squared is equal to 5 squared is 25 plus 4. That's 29. So, square root of 29 is... Well, let me do that thing I did last time. Okay, buddy. Desmos. Square root of 29 is 5.38. 5.39. 5.39 meters a second. That's what I got for this one right here. So that's the what would you call it? I guess average direction. It's how fast it's moving. That's average velocity when you oh my god, include the fact that it's not only going forward but it's also going to the right, or not it's not only going north but it's also going to the east, you know. Right? This is 5.39 meters a second. So yeah, that's that. This is number 1. With respect to okay. How much time will it take the boat to cross the river? Show all your work. So it has to go forward 40 meters. We know that. Hold on. Let me zoom out a little bit so we can see all this. Okay, so it has to go forward 40 meters. So no matter what, the boat will go forward 40 meters at 5 meters a second because that's how fast it's going forward. So it's going forward 40 meters. And here. It's going forward. Wow, it looks horrible. It's going to have to go forward 40 meters. And while it's going 5 meters a second. It's going forward 5 meters a second. Which means all you have to do is divide this by 5. 40 divided by 5 is 8. And that's how many seconds it's going to take to go forward. And that's really how fast that's how long the boat's going to travel in general. So, now that we know that, we can also calculate about how much time, well, actually, that's the answer that we need for this one. 8 seconds. Which we got because, again, we know that the boat's going to go 40 meters forward, and it's going 5 meters a second forward. So, it takes 8 seconds for it to go make the trip of 40 meters forward, and it's also going to go east in that time, but we don't know that yet, so I'm pretty sure. Calculate the value of x. Yep, see, that's what we're doing now. So if it's going to take 8 seconds to make the trip, and it's going, 2 meters per second east. 2 meters per second east, and again, we know it's going 8 seconds in total. Then, all we gotta do, multiply this by 8, because you get 2 meters every second. So 2 times 8 is 16. So it would have gone 16 meters this way. Oh, let me just remake it. It would have gone 16 meters this way in 8 seconds, as well as 40 meters forward. 40 meters forward. So, now, that's the value of x. Perfect. 16 meters. That feels right. Now, and that is, yeah, it's right here. So that's how far it's going to travel, and that's 16 meters. Oh my god, that doesn't make sense. Wait, how is that 40 meters, but this is 16 meters? This is weird. I feel like there's something wrong there. What did I do? Read it again. Water in the river moves uniformly to the east with the speed of a boat. Starts at the south edge of the river. Has a speed of 5 meters a second. The width of the river is 40 meters. When the boat reaches the north edge of the river, it has an eastward displacement of x relative to its starting position. That's weird. Relative to starting position, so like right here then. So I have to go this way, and that looks larger than 40 meters though. That's weird. This one, honestly, this one's kind of weird. Kind of stumping me. I'm not sure, but I mean, this is what I got. So, I mean, I guess just let me know if you got something different. When the boat reaches the north edge of the river, so over here, it has an eastward displacement of x relative to its starting position. Also, I don't think this one, magnitude and direction. Okay, well, I mean, yeah, that's everything I got. So, yeah, pretty short stream, but this is everything I got. So, fact check it, and if I did something wrong, let me know. Okay, bye.